In this video, we're going to look over the radian measure. So this is chapter 7, circular measure. So how do we measure in radian? Now, radian is the SI unit. So it's the System International Unit to measure angles. All right. So now, how do we define a radian? How do we measure in radian? And to do so, we take a circle. This is a very bad circle, but I think, okay, this is an ellipsoid. I'm sorry. So let me try to draw a circle here. All right. Okay, something like this. So this is a circle. And from the center, I will draw the radius of the circle. Let's call it R. And I will take some curved length from the point where I drew my radius, right? So I drew my radius here. So I'm going to start and I'm going to take this curved length and I'm going to call it L. That is going to be my curved length. And now wherever I stopped taking that length, I'm going to draw my radius again. So this is going to be my R again. And if you want to know what is the angle, theta, formed between these two radians, right, the radii that we have drawn, well, the angle in radians, which is our new unit, the angle in radians, so theta, the angle theta in radians is going to be equal to this ratio L divided by R. So if you want to know what angle this theta is, then you need to do this L, which is the curved length, divided by R. So that is how you find out radians, right? So if you are given a diagram and you need to find the angle in radians, this is the formula that you are going to use. And now what is 1 radian? How do we define 1 radian? Well, how do we get 1 on the right-hand side here? If L is equal to R, R divided by R will give me 1, right? So 1 radian is the angle, which is this theta, subtended when the arc length, which is this curved L of the circle, is equal to its radius. So that is going to be 1 radian. So 1 radian is still going to be L by R, but here L has to be equal to R. So this curved length, if it's equal to the radius, then this angle here, if this curved length is equal to the radius of the circle, then this angle theta is going to be 1 radian. And if you just are given L and you want to find the angle subtended in radians, then it's going to be L divided by R. And from this, you also know that from this, you can also deduce that L, the arc length, is R theta. The arc length is R times theta. The radius times the angle in radians. So we are now working in radians. If you put degrees, it's not going to work. All right. So now that we are sort of done with the idea of radians, how do we convert? So we are familiar with using degrees. So how do we convert? Okay, let me keep the diagram for a while. So how do we convert? Well, let's think about this. How many degrees are there in a circle? Well, that's 360 degrees, right? Now, to get a full circle, I need to start here and I need to take the whole circle. Now, what is the length of this green part? Well, that is the perimeter. And the perimeter is just 2 pi r, right? That is the perimeter. So what is the angle theta? Use this formula. Theta is L divided by R. Well, the length, the arc length for the whole circle is just 2 pi r. And if I divide by r, then I see that I get 2 pi. So 360 degrees in a circle, but in radians, we say that we have, so it's not exactly equal. It corresponds to 2 pi radians. 360 degrees corresponds to 2 pi radians, right? And now from this, we can deduce that if you divide by 2 on both sides, 180 degrees is going to correspond to pi radians. And that is what you need to know. 180 degrees is pi radians. And that is all that we are going to need to convert. All right. So now that we are done, we can start doing some questions. And it's very, very helpful to know some very basic conversions. So it's very, very helpful to memorize these. So 2 pi radians is 360 degrees. Pi radians, so I'm just going to say is, pi radians is 180 degrees. Pi by 2 radians is 90 degrees. Pi by 4 radians is 45 degrees. Pi by 3 radians is 60 degrees. Pi by 6 radians is 30 degrees. Pi by 12 radians is 15 degrees. So it's very, very helpful to know these conversions. So it's just very helpful to memorize. And you can just start from this point, actually, and figure everything else out. But it's just helpful to have these ones in mind, because you're going to use it for physics and oscillations. You're going to use it for sine curves when we discuss trigonometry later. So these special angles are going to come up again and again. And you need to know them in radians off the back of your head. All right. So I hope you took a note of it, or you figured out the conversions. But now we are going to do some questions. All right. So change these angles to radians, giving your answers in terms of pi. So we won't do all of them. I'll just pick a few to do the conversion. So let's start with A, right? 1A. So what do we know? We know that 180 degrees is equal to pi radians. That is something we know. So 1 degree is going to be pi divided by 180 radians. So I have 180 degree corresponding to pi radians. So if I need 1 degree, I need to divide by 180 on both sides, right? So I get this relationship. 1 degree is pi over 180 radians. And if you need 20 degrees, then, well, 1 times 20 is going to give you 20. So you need to multiply by 20 on both sides. 20 radians. And if you simplify, you are going to get, I believe that this is going to be pi over 9 radians. That is your answer, pi over 9. And let me just quickly check it for you. Yep, it's pi over 9. So same with 40 degrees. Now, if you know 20 degrees, right? 20 degrees times 2 is going to be 40 degrees. So you just need to multiply this by 2. So 2 pi over 9 radians is going to be 40 degrees, right? So this was pi over 9. This is going to be 2 pi over 9. So now let's start again. I know 180 degrees is pi radians. 1 degree is just pi over 180 radians. So 25 degrees is going to be pi over 180. So 1, I need to multiply by 25. So I need to multiply pi over 180 by 25 to get my answer in radians. And if you simplify this, 180... So if you simplify this, I believe you should get 5 pi over 36 radians. All right. So that is 25 degrees. 5 pi over 36 radians. And I hope this was clear. So you start with 180 is equal to pi radians. 180 degrees is pi radians. So 1 degree has to be pi divided by 180. You divide by 180 so that if you divide by 180, you get 1 here. You need to divide by 180 as well. And if you multiply by 25 here, you do that here as well. And that is how you convert. And you get 5 pi over 36. Or you could follow the textbook. They just give you directly how you can convert. So to change from degrees to radians, we multiply by pi by 180, right? To change from radians to degrees, you multiply by 180 by pi. So you can follow this, or you can just do it like this as well, whichever you find easier. So now, if 25 degrees is this, 50 degrees is just going to be the double of it, right? So 50 degrees is just going to be the double of 5 pi over 36, and you are going to get 5 pi over 18 radians, right? If 25 degrees is 5 pi over 36, 5 degrees is just whatever this is divided by 5. So you are going to get pi over 36. If 50 degrees is this many radians, 150 degrees is just 50 times 3. So if you multiply this answer by 3, you get 15 pi by 18 radians. Yeah, 15 pi by 18. And you can simplify this because both of them have 3 as a common factor. So 5 3 is a 15, 6 3 is a 18. So you get 5 pi over 6 for f, right? So if you know one and you know the factors, it's very easy to compute, right? 50 degrees is 5 pi over 18. What's 300 degrees? Well, 300 is just 50 times 6. So you need to multiply 5 pi over 18 by 6. So you get 30 pi over 18, which is just 15 pi over 9 for J. And you can do it further, actually. You could get 5 pi over 3, right? Because 15 and 9 have 3 in common. All right, so what is 225 degrees? 180 degrees corresponds to pi radians. 1 degree, I divided by 180, so I need to do pi over 180 radians. And 225 degrees is going to be pi over 180 times 225 radians. And if you simplify this, both have a common factor in 5. So 5 times 45 gives you gives you 225, and then 180 can be 5 times 36. And these cancel out. And you have 45 pi over 36, which I believe you can simplify further. Yeah, because it's 9 5 and 9 4. So you have 5 pi over 4 for I. Yep. So 225 degree is 5 pi over 4 radians. Radians. The symbol is going to be RAD. And that is it. So that is how you are going to approach question 1. And question 2. So the first row are things you want to remember. Pi by 2 is 90 degrees. Pi by 3 is 60 degrees. Pi by 6 is 30 degrees. Pi by 12 is 15 degrees. This is something I already gave you, right? So these are the numbers you want to keep in mind, along with some others, special others, right? Now, if you are given 4 pi over 3, I know pi radians is equal to 180 degrees. Now, how do I make this 4 pi over 3? Well, first, let me multiply by 4. So 4 pi radians is going to be 180 times 4. That is 720 degrees. And now I need to divide by 3. So 4 pi over 3 radians is going to be 720 degrees divided by 3. And how many degrees is that? That is 240 degrees. And we are done. So that is how you convert, right? So E is 240 degrees. And it's the same procedure. Pi radians is 180 degrees. So if you want 4 pi over 9, we'll first multiply by 4. 4 pi radians is going to be 720 is going to be 720 degrees. And 4 pi over 9 radians is going to be 720 degrees over 9, which is 80 degrees. And it's the same for g as well. So 3 pi over 10, right? So pi radians is 180 degrees. 3 pi radians is equal to sorry about that. So 3 pi radians is going to be 180 times 3. That is 540 degrees. And 3 pi over 10 radians. So you just divide by 10 on both sides, you get 54 degrees. Alright, so I'm going to leave the rest to you so that you get more hands-on practice. Question 3 is the same question, right? Write each of these angles in radians correct to 3 significant figures. So they want more, they just want to plug it in your calculator. So 180 degrees is pi radians. 1 degree is pi over 180 radians. And basically, pi over 180 times 28 is going to give you your value in degrees, right? So this is just going to be, you take your calculator, you punch pi over 180, and then you multiply by 28, and you get 0.489 radians to 3 significant figures. And what is, let me do one more. So what is 200 degrees? Well, 1 degree we figured out is always going to be pi over 180 radians, right? So what is 200? Well, it's just 200 degrees. It's just pi over 180 times 200. And if you simplify, you get 3.49 radians. And that is it. So that is how you're going to do question, I believe that is 3. I don't even know anymore. Yeah, 3. And question 4 is the same. Write each of these angles in degrees correct to 1 decimal place. So we know pi radians is 180 degrees. What is 1 radian? 1 radian is just 180 divided by pi degrees. So 1.2 radians, I just need to multiply by 1.2. Need to multiply this by 1.2. So 180 divided by pi times 1.2. And if you put that in your calculator, you get 68.8, I believe, to 3 significant figures, but they wanted to 1, I think, to 1 decimal place. So it's just going to be 68.8 degrees. So this is 68.8 degrees. That is it. And let's do one more. 0.79 radians. So if I know 1 radian is 180 by pi degrees, then 0.79 radians is just 180 by pi times 0.79. And if you do that, 180 by pi times 0.79, you get 45.3. So this is going to be 45.3 degrees, approximately, to 1 decimal place. So that is how you're going to do question 4, and I'm going to leave it to you. So now these are the special angles that we discussed. So 45 is pi over 4 radians, 90 is pi over 2, 135 is 3 pi over 4. 135 is 45 times 3. So this you have to multiply by 3, right? Now 225, I believe, is also a multiple of 45. So 45 times 5 gives you 225. So you have to multiply pi over 4 times 5. So pi over 4 times 5 is going to give you 5 pi over 4. 270 is 90 times 3. So it's going to be 3 pi over 2. 315 is also a multiple of 45, I think. It's 7. So if you think 45 times 7, so 7 times pi by 4 is going to be your answer, and you are going to get 7 pi over 4. So that is how you do the conversion very quickly. And pretty much, the part B is the same. 30 is pi by 6. You just have to remember some of these values. if you remember, it's going to be very, very helpful rather than having to calculate it every time. 60 is pi by 3, 90 is pi by 2, 120 is 60 times 2, right? So pi by 3 times 2, 2 pi by 3. 150 is 30 times 5, so it's 5 pi by 6. 30 times 5, 60 times 2 gives you 120. 30 times 5 gives you 150. What's 210? 210 is going to be 30 times 7. So it's going to be 7 pi over 6 times 7. 240 is going to be 60 times 4, right? So it's going to be 4 pi over 3. 270 is 90 times 3, so that is 3 pi by 2. 300 is 150 times 2, right? 150, so it's going to be 10 pi over 6. And you can simplify this. You can write it as 5 pi over 3. And 330 is going to be, you can say it's 30 times 11, right? 30 times 11 is going to give you 330. So that is just going to be 11 pi over 6 and 2 pi. So that is how you can do. And so you want your calculator for this question to be in radians mode. So you just put your calculator in radians. So you go to mode, you switch to radians, and then you just say sine 0.7 is just 0.64421. I'm keeping to 3 significant figures. Cos pi over 2. Cos pi over 2. Cos 90 is 0. Sine pi over 3. Sine, that is sine 60, is root 3 over 2. If you put sine pi over 3 in your calculator and you find root 3 over 2, you should get the same answer. Tan pi over 5. So that is not a standard angle. Tan pi over 5 is about 0.727. So 6.5 is, I rounded to 7. So you just use your calculator to find. And you just want everything to be in radians. And I think that is it. If I made any mistakes, do feel free to point it out. I don't think I did. But yeah, always room for mistakes. And I think it should be correct. Yeah. Okay. So calculate the length of QR. So if you take... Now you have to remember some of your basic trig. So you have so, ka, toa. That helps, right? And QR is at the opposite. You are given your adjacent and you are given your angle, right? So opposite, adjacent, we have that. So it's going to be tan, T for tan. So tan of 1 radian is opposite, which is what we are looking for, QR, over our adjacent, which is 5 centimeter. So QR is going to be 5 times tan of 1 radian in centimeters. So 5 times tan of 1 radian gives you 7.787. So that is just going to be 7.79 centimeters in 3 significant figures. For the last question, it's Kinley is told the size of angle BAC. BAC, A is in the middle, so it's this angle. And he's then asked to calculate the length of line BC. Now let's look at BC. Let's look at our SOHCAHTOA again. So remembering some basic trigonometry from grade 10 or 9. BC is opposite of angle theta. The hypotenuse is always opposite to the right angle, right? Right angle is here, so this is the hypotenuse. So this is H. So I want to find this, I am given this. So I'm going to use the sine of the angle is equal to BC over H, which is 6. So basically, 6 sine theta is equal to BC. Alright, so he uses his calculator but forgets that his calculator is in radian mode. Luckily, he still manages to obtain the correct answer, given that it's... So basically, he was given it in degrees and he used radians. Alright. So the actual question is you have 6 sine theta in radians gave you the same answer as 6 sine theta in degrees. That is what they're practically asking us if you think about the question, right? So we want to find what angle for which the sine is equal in degrees and radians, and we are given the restriction theta is between 15 and 10 degrees, right? All right, so now we are asked to use a graphing software to help us find the angle BEC. So we are going to plot. So if you go to a graphing software, which I am going to do so right now, this is Desmos, right? So sine x, the default plot is in radians because SI unit, right? So here, sine x, it's plotting in radians. And if you want to plot in degrees, you have to multiply x by pi over 180. So now let's think about why is it pi over 180. So we can see sine x was already plotted, and this was in radians. Now sine x times pi over 180 gave us the plot in degrees. Now to just be sure of why this works, you can just substitute some values of x inside. If you substitute x to be, so we are here, x is in degrees, not radians, right? So if you substitute, so you plotted x in radians, the second time you're plotting x in degrees, right? You're plotting x in degrees. So but Desmos can't plot in degrees. So what you do is you take your x in degrees and you convert it to radians like this. And it works, right? So you convert it to radians by doing so. So if you put 180 degrees here, 180 cancel out, you get pi radians as usual. If you put 360 here, you get 2 pi radians as usual. So you know that it works, right? All right. So now that we have the plot, we just want to go between 10 and 15. 10 and 15, 10 is here, somewhere here. 15 is somewhere here. So their intersection is here. So to 2dp, I think that is what the question asks. Your x coordinate is 12.789. So your x coordinate is 12.789. And to 2 decimal places, this is going to be approximately 12.79. So sine 12.79 degrees should approximately be equal to sine 12.79 radians is what we are seeing. And if you just plot it, so sine, if you use your calculator, 12.79 first in radians, this is 0.2217700 and if you do it in degrees, if you do sine 12.79 degrees, you get 0.2213. So it's correct to 2 decimal places. It's actually 3 decimal places, right? So yeah, that is it. This is your answer. All right, and that is it for this topic.